Welcome to the project demonstration of power flow improvement in transmission lines using UPFC, so Unified Power Factor Correction. So we are going to achieve this system by using of this PIC microcontroller. So here the main system is we are going to monitor the power flow and the inductive load and the difference between the phase and voltage of waveform and current waveform. So in this transmission lines, so this is the transmission lines, and we are going to we connected the bulb and inductor in series, and these two loads R plus L are parallel with this capacitor and with the relay switch. So this is the main connection. So here is the CT, and we are going to check the current waveform and voltage waveform from this PT. Okay, so this section is going to be the controlling part and monitoring part, and this one section is going to be the transmission line part. So coming to the block diagram of our project. So this is the block diagram of the project. So in this one we can observe, so this is regulator power supply, and this is the main, it's controlling monitoring part, and the below, so the zero crossing detector and current transformer and resistive loads along with inductive load. So these two is going to be the parallel with the capacitive bank with relay switch. So whenever we added this inductive load, then automatically there is a phase difference between the current waveform and voltage waveform. That will be identified by our PIC microcontroller, so by using the zero crossing. So when the voltage waveform is zero crossing and when the current waveform is zero crossing. So based on the difference between the time difference between these two, we are going to get the degree of angle. So nothing but we are using 50 hertz of our input voltage frequency, and 50 hertz nothing but it's going to be the 20 milliseconds per one cycle. So nothing but 1 second 50 hertz is, and nothing but 1 second 50 pulses, and then for one pulse it will take 20 milliseconds. 1 by 50 equal to 20 milliseconds. In 20 milliseconds we are going to get the full sine wave. Means in full sine wave it will take 20 milliseconds. Nothing but 20 milliseconds is equal to 360 degrees it's covering, right? Positive 180 and negative 180 is called 360 degrees. So means 20 milliseconds equal to 360 degrees. So what is the phase angle time difference? So in that manner, so 20 milliseconds 360, if then what is the x time in x degrees? So the degree will get that. If it is 0, then cos 0 is equal to 1. If it is more than difference is more than 0, then the cos some degree value is equal to less than the 1. So that will be identified our PIC microcontroller, and based on that value we are going to on this capacitor, because the capacitor will lead the waveform, inductor will lag the waveform of current. So then these will be compensated. So that is why in this way we are going to correct the power factor in power lines. So let us see the demonstration. So just give the two power supplies for the system. So one, the main motherboard will get switched on, and the next one is switch on the load. So now we can see this, right, and welcome message will be displayed, and now it will take more time initially to calculate. So till that, so around of 30 seconds you can hold this reset switch, keep on restarting, because it has to calculate the first value, right? So you can neglect the starting 30 seconds. You should allow the microcontroller to calculate the angles. So when only resistive load is there, then we are not supposed to allow the microcontroller to switch on the relay. So when it is getting on, then you should restart the microcontroller. Now it's settled down, and now the power factor is going to be the 0.97. Though we are using the resistive load, but it's not going to be the unity power factor. It's near to unity power factor. And now when I added this inductive load, so my inductive load got added. So that's why the V1 and V2 is divided. That's why inductor load came to the picture. Power factor comes down to 0.83, and already the capacitor got switched on. You can see the LED, and now it will be start compensating. Right, it's compensated, and the power factor is going to be the 0.93 now. And then if I isolate this inductor from the resistive load, then the brightness will increase, as well as R plus C are in parallel. Then the power factor has to lead. So let me check. So it's starting the calculating, so it will take some time. Now we need to restart. Now see, it's coming to that, and let us see that the capacitor is still in parallel. And now once it get the perfect readings, then it will display the either with it leading or lagging. Now it's displaying that power factor is 0.95, but it is leading. It will be fluctuating. It will be settled down within a seconds. Yeah, right. Already when it is showing the leading, then and there only the relay got already switched off. So we need to observe that. So it's all happened. So in this manner we are going to compensate, and we are going to improve the power flow improvements in transmission line using the UPFC concepts. Thank you.